Hello everyone, welcome back to this video on digital communication. In this video I am going to talk about the code division multiple access in detail. So I have already talked to you about the various types of multiple access techniques. You can go and watch my previous video to know more about the multiple access technique. In that video, I introduced CDMA. So there I told you CDMA is a technique where we use orthogonal codes to transmit different signals over the same channel. So I already told you that it is used in third generation wireless communication or specifically data transfer. So I can say code division multiple access uses orthogonal codes to transmit different signals over the same channel, and it is used in third generation wireless communication or specifically third generation data transfer like CDMA 2000, WCDMA. I already talked about the difference between CDMA 2000 and WCDMA. WCDMA has higher bandwidth. So now after that it is used in HSUPA and HSDPA. HSDPA means high speed downlink packet access. Similarly HSUPA means high speed uplink packet access. So in short it is used in 3G wireless communication. So now what is code division multiple access? If I have a single channel, so let's suppose this is my channel. So here I have 4 users. So this is my user 1, this is my user 2, this is my user 3, and this is my user 4. So I have 4 users here which are using the same channel. So this is my channel. So now the user 3 would have data 3, user 4 would have data 4, user 1 would have data 1, and user 2 would have data 2. I am just classifying their data. Every one of them are having some data. So now I am multiplying the user 1's data with the code 1. So D1 C1, here I am giving D2 C2, here I am giving D3 C3, and here I am giving D4 C4. So these C1, C2, C3 and C4 are orthogonal. So now what would happen in the channel? In the channel I would be having D1 C1 plus D2 C2 plus D3 C3 plus D4 C4. So this thing I would be having in my channel, and let's suppose the 3 codes, I am taking the 4 codes orthogonal to be like 1, 1, 1, 1, C2 to be 1, minus 1, 1, minus 1, C3 to be 1, 1, minus 1, minus 1, and C4 to be 1, minus 1, minus 1, 1. So these 4 set of codes are orthogonal. So let's understand how these codes are orthogonal in nature. So if I multiply any of the 2 codes, so let's suppose I am multiplying C1 with C2. So the first code is multiplied with the first code, here I'll get 1. So this code is multiplied with this code, I'll get minus 1. This code is multiplied with this code, again I'll get 1. This code is multiplied with this code, I'll get minus 1. So 1 plus minus 1 plus 1 plus minus 1 is equal to 0. So I can say C1 and C2 are orthogonal. So let's suppose I am taking another set of code. So I am taking C2 and C4. So let's check it for C2 and C4 as well. So 1 into 1 is 1, minus 1 into minus 1 is 1. 1 into minus 1 is minus 1, minus 1 into 1 is minus 1. So again it is 0. Plus if I talk about a single code, so if I multiply C1 with C1 only, or C1 is all positive, so let's take another example. If I am multiplying C3 with C3 only, so what would happen? 1 is multiplied with 1, I'll get 1. 1 is multiplied with 1, I'll get 1. Minus 1 when multiplied with minus 1, again I'll get 1. Similarly here also, Minus 1 when multiplied with minus 1, again I'll get 1. So when the same code is multiplied with itself, I'll get 4. And when two different codes are multiplied, every time I'll get 0. So this is the property of orthogonal codes. So I can say these are C1, C2, C3 and C4 are orthogonal. So now let's suppose the data transmitted by 1 to be A1, 2 to be A2, 3 to be A3 and 4 to be A4. So now the data transmitted also follows some property. If the data transmitted is 1, I'll denote it by A. If the data transmitted is 0, I'll denote it by minus A. And if no data transmit, if my user is silent, if no data transmit or the user is silent, so I can say it is denoted using 0. So now let's suppose 1 is providing A1 and I am choosing 1 to be A, 2 to be A, 2 to be minus A, 3 to be A and 4 to be A. So this is my data which every user is giving. So user 1 is giving, in short, A is represented by 1, minus A for 0, A, 1, A1. So now what is happening? Actually user 1 is giving the data A, which is representing 1. So the user A or user 1 has the data 1, or user 2 has the data 0, user 3 has the data 1 and user 4 has the data 1. So these all datas are combined with the code and given to the channel. So this is what happening. So my data, any of the user is not silent. Every user has some data. I just denoted the data. The first user had the data 1, which is denoted by A. Second user had the data 0, which is denoted by minus A. Third data had the 1 denoted by A. Fourth data 1 denoted by A. So now in the channel, what would I get? In channel, the data 1. So this is my D1, this is my D2, this is my D3 and this is my D4. So now data 1 or D1 is A, is multiplied with C1. C1 was 1, 1, 1, 1. So plus D2 multiplied with C2. So D2 is minus A. It is multiplied with C2. 1 minus 1, 1 minus 1. Plus D3. Now D3 is again A, which is multiplied with C3. 1, 1 minus 1 minus 1. And data 4 is A, which is multiplied with C4. 1 minus 1 minus 1, 1. So now if I send this, what will I get? So I'll get here A plus minus A when multiplied with minus 1 I'll get, so I'm taking this to be one data, minus A when multiplied with minus 1 I'll get A, minus A when multiplied with 1 I'll get minus A, here A plus A minus A minus A plus A minus A minus A. So let's understand what would happen at the receiver. So this is the code which is in my channel. So this is the code which is in my channel code. So this full code is present in my channel. So what happens at the receiver? At the receiver, if I want to receive, let's suppose data 2. I want to receive data 2. If I want to receive data 2, what would happen at the receiver? The same code, this 1 minus 1, 1 minus 1 is multiplied with the channel code. So this CX is multiplied with C2, then I'll get the received data of 2. So let's verify it also. So this is my CX. So it is A plus minus A minus A plus A minus A minus A plus A minus A minus A multiplied with C2 is 1 minus 1 1 minus 1. So when all of the data is multiplied with 1 minus 1, 1 minus 1, I hope you can see this would be A multiplied by 1 would be A. So first digit is multiplied with the first code, which is A. After that, second code, so minus 1 is multiplied with A, I'll get minus A. Here 1 is multiplied with A, I'll get plus A. Here minus 1 is multiplied with A, I'll get minus A. Similarly, here minus A multiplied with 1, I'll get minus A. Minus 1 multiplied with A, I'll get minus A. 1 multiplied with minus A, I'll get minus A. And minus 1 multiplied with A, again I'll get minus A. Plus here 1 multiplied with A, I'll get A. Minus 1 multiplied with A, I'll get minus A. 1 multiplied with minus A, I'll get minus A. And minus 1 multiplied with minus A, I'll get plus A. Plus again 1 multiplied with A, I'll get A. Minus 1 multiplied with minus A, I'll get plus A. 1 multiplied with minus A, I'll get minus A, and minus 1 multiplied with A, I'll get minus A. So from here, if you add all of them, so now I am left out with minus 4 of A. So now I am getting minus 4 of A. So if I normalize it, I'll divide it by 4. So which is minus A. So the user 2 sent minus A, so the user 2 sent minus A, and we also received minus A. So this is the code division multiple access using the pseudo random codes, or we can say we are using the direct sequence spread spectrum in code division multiple access. I hope you understood how I am using the pseudo random code in the generation. Here I generated the code and here I received the code with the help of again pseudo random code. Here I multiplied the data with the pseudo random code. The code was generated. Here at the receiving end also I multiplied it with the code again so that I'll get the data back. I hope you understood this. If you still have any doubt, you can put your doubt in the comment box below and I'll try to resolve it as soon as possible. I hope you like this video. If you like it, share it with your friends, subscribe to the channel and push the like button. Thank you.